Machine learning overview. What is machine learning? Machine learning is a branch of artificial intelligence that focuses on building systems that can learn from data. Instead of programming a computer with exact instructions, we give it data and let it find patterns on its own. It is used in prediction and decision making. Types of machine learning. There are three main types of machine learning. First is supervised learning, where the model learns from labeled data. Second is unsupervised learning, where the model finds patterns in unlabeled data. And third is reinforcement learning, where a system learns by interacting with an environment and receiving feedback. Each type is used for different kinds of problems. Types of supervised learning in machine learning. In supervised learning, the model is trained using labeled data, which means we already know the correct answers. There are two main tasks, classification and regression. Classification predicts discrete categories or puts things into groups. Example, cat versus dog image classification. Regression predicts continuous values or numbers. Example, salary prediction based on experience. One of the common algorithms is the linear regression. Linear regression is a method used in machine learning to predict a value based on a relationship between two things. The key idea is to draw a straight line, the best fit line through the data points so we can make predictions. Each dot represents real data and the line is our prediction model. A second common algorithm is the decision tree. Decision trees are tree-like structure for decision making. They make decisions step by step like a flowchart. The image illustrates the concept of a decision tree, a popular supervised learning algorithm used in machine learning for both classification and regression tasks. The tree begins with a root node asking a question. Is it raining? Based on the answer, if yes, the tree follows one branch. If no, it follows another branch. Further, decisions or nodes refine the outcome until a final action is reached. Go by car or ride a bike. Unsupervised learning in machine learning. Unsupervised learning works with unlabeled data. It does not have predefined answers or labels. The goal is to uncover structure that isn't obvious. It finds relationships, groupings, or trends in the data. Some of the common tasks are clustering, which is grouping similar data points together, or dimensionality reduction, reduces the number of features or variables while keeping important information. Now, let's look at the algorithm. K-means is an AI algorithm that automatically groups similar data points together into a set number of clusters, K, based on their closeness to a central point. This image provides a visual overview of K-means clustering, a fundamental machine learning method used to discover hidden patterns in data without using pre-existing labels. Here's how the process works. Number one, initialization. We start with a set of unlabeled data points. We choose a value for K, which represents the number of distinct groups we want to identify. Number two, defining centers. The algorithm places K initial starting points, known as centroids, randomly among the data. Three, assignment. Each data point is assigned to the group of the centroid it is closest to, usually measured by a straight line distance. Number four, optimization. The centroids automatically shift their positions to the center of their new groups. This cycle repeats until the centroids stop moving. Number five, final result. The once random data is now organized into clear, color-coded clusters where similar items are grouped together. Another algorithm is the principal component analysis, PCA. It is a technique that simplifies complex, high-dimensional AI data by compressing it into fewer variables while keeping the most important information. Reinforcement learning. Reinforcement learning is based on trial and error. An agent interacts with an environment and receives awards or penalties based on its actions. Over time, it learns the best strategy to maximize rewards. This approach is used in areas like robotics, game playing, and even self-driving cars. Applications of machine learning. Machine learning is used in many real-world applications. Recommendation systems suggest what to watch or buy. Image recognition helps identify objects or faces. Natural language processing powers chatbots and translation tools. Fraud detection systems help banks identify suspicious transactions, and autonomous vehicles use machine learning to navigate roads. Conclusion. In summary, machine learning is transforming industries and creating new opportunities. Understanding the basics of machine learning is becoming an essential skill, regardless of your field.